Right, good morning, grade 11s. Today we are going to start with the next and the last trig work of your grade 11 syllabus, and this is the trig measurement section. So just to give you an idea what we are going to look at during this chapter 11, we're going to look at some grade 10 revision working with triangles. Then new to grade 11 is the area rule, the sign rule. And then with the sign rule, there is a topic called the ambiguous case. Then we're going to do the cosine rule and the heights. So what is the big difference? In grade 10, you only worked in triangles that were right-angled triangles. Okay? The area rule, the sign rule, and the cosine rule are based on triangles that will not be right-angled triangles, and you will have to determine angle sizes and side lengths in all of them. The area rule, I'm going to refresh your memory that the area of a right-angled triangle is half base times perpendicular height, but I'm also going to show you how I can determine the area of a triangle that is not a right-angled triangle. Okay, so that's just an introduction to what you're going to do during this chapter. So for the first lesson, we are going to revise of how we would solve triangles if they were right-angled triangles. Now, when I do grade 10 trig, I go through the following steps of my grade 10s. First, I would encourage you using a highlighter. The first step is to identify the angle, then label the sides accordingly to that angle that has been identified, and then determine the ratio you will be working with. So what did they give me? What do they want to have worked out? So it's either O over H, which is sine, A over H, which is cos, and O over A, which is tan. And then I will use my calculator basically to solve it. Okay. So when I look at the first example, and this is a purely grade 10 question, I would say to you, determine the length of BC. Now let's just go through some key aspects that you're going to encounter in your grade 11 trig. If I have triangle ABC, instead of referring to side AC as AC, I can refer to it as side B. So angles are given by capital letters, lengths of sides are given by small letters. So opposite angle B, I will find side B. Opposite angle A, I will find side A, and opposite angle C, I will find side C. This was one of your introduction lessons in grade 10. So let's stick to the steps that I have highlighted there in the beginning. So identify the angle. So I just like to make it very clear to myself. There is angle C that they gave me. Touching angle C is my adjacent side. Opposite the 90 degrees is my hypotenuse. And then opposite the given angle, that is my opposite sides. The reason why I'm writing OPP for opposite and ADJ for adjacent is because there are so many letters already, I don't want you to get confused. So now you have to ask yourself, what do they want me to work out? So they want me to work out the length of BC. What did they give me? So when I combine what I want and what I have, I see I have A and H. And A and H is cos. Okay? So cos of 28 is equal to A over H, that is side BC over 35. You could have named side BC as a small a as well. Right. Calculator then, the 35 moves over. I have cos 28 degrees, and that will give me BC's length. I just enter it into my calculator as it is, and I get 35 cos 28, and depending on the instruction of rounding off, let's make it 1 decimal, and if they didn't give me units, you are welcome to put it down there. Okay. Also done in grade 10 is angle of elevation and angle of depression. So just to recap it, if I have two parallel lines, depressed, I'm looking down, elevate, I'm looking up. Okay, that's the long and the short of that. So if I look at this question, example 2, angles of elevation to the top of the windmill is 15. So there is my two parallel lines. That is my angle of elevation and 20 degrees respectively. So if you had to, you could have said that that will be 20 as well and that will be 15 as well, because it's alternate angles. FH is the perpendicular height. That means from F to H, I will have a line that makes 90 degrees. And they say it will have a length of 11 meters. Calculate the distance between B and A. So the distance BA can be worked out by working out the length of BH and working out the length of, HA. Because if I add those two, I get BA. So if I had to isolate these two triangles, that's 11, that is 20. Highlight what the angle is, label the side, opposite, adjacent, hypotenuse, determine what you have and what you want. I have 11, I want to work out that A, so O and A is tan. So tan of 20 is O over A, which means A tan 20 is 11, and A will then be 11 over tan of 20. And 30,2. So that is then basically the length of BH. If I had to isolate the triangle FHA, that is 15. So that's my angle, hypotenuse, adjacent, and opposite. And my opposite side is 11. What I have, what do I want? Once again, I'm going to work with tan. So tan of 15 is 11 over A. So A is 11 over tan of 15. So that works out to be 41,1. So BA is 30,2 plus 41,1. 0.1, sorry. And you will get BA has a length of 71,3. Okay, depending on what your instruction will be. Right. They can also say to you, without a calculator, you will need to work out the following. So if I have triangle ABC given that side BC has a length of 4 and angle A has a size of 53.7. And this is from exercise 11. Oh no, sorry, that was the wrong one. This is question A that you're going to do at home. Okay, I don't want to look at A. This is a homework question. I want to look at where is all my, I want to look at B. Okay, so exercise 11.1, I want to look at 1B, and they say to me, C has a length of 25, A has a length of a size of 60, and you are working in triangle ABC, and angle C is your 90 degrees. Okay, so angle C is 90, ABC. A is 60. Side C will be opposite angle C. Okay, and they want me to work out remaining angles. So they want me to calculate angle B. They want me to work out length of CB and the length of AC. That is my instruction. Okay, so highlight what you have, label your sides in terms of that angle, that's adjacent, that is opposite. Okay, I can find angle B by saying 60 and 90 is 150, B will be 30 degrees, and my reason for that is sum of angles in a triangle. Okay, I can now go on to solving lengths of A and O. So if I first decide to work with what I want, what do I have? I'm going to work with A over H, which is cos of 60. So that's AC over 25. So 25 cos of 60 equals to AC. The moment they say to me without using a calculator, I need to be able to do this. So that's 0 and 2, so that's 1 and square root 3. That's square root 2, square root 2, square root 3, and 1, because that is 2 and 0. So that's 30, that's 45, that is 60. You don't get a mark for that. You just have to be able to do that. So cos of 60, I'm going to have, it's A over H, so that's a half, is equal to AC. So AC will have a length of 12.5. Okay, now working out the third side CB, I have one of two options. Because this is a right angle triangle, I can do Pythagoras or I can do trig. Okay, I'm going to do both. So trig-wise, what do I want? What do I have? That is sine of 60 is then CB over 25. So 25 sine 60 will give me the length of CB. Sine is O over H, so 25 is square root 3 over 2 equal to CB. Now I can take my calculator and work out what is the square root of 3 over 2 times that, or you can just say it's 25 square root 3 over 2 because top times top, bottom times bottom. That's my answer. And you can go a step further and say, hold on, that's then 21,65. Okay. If you used Pythagoras, you would have had to say that AB squared is equal to AC squared plus CB squared. Why am I using that? Because of Pythagoras. So 25 squared minus AC is 12,5 squared will give me CB squared. So if I use the square root of 25 squared minus 12.5 squared, CB will have a length of 25 square root 3 over 2, which then gives me the same answer. All right. So I'm just checking what I wanted to do any further. No, that's it. Okay. So what you need to do now, please, is exercise 11.1 on page 297, number 1 AC, number 2 AD, and number 5A and